So hello and welcome to all. My name is John Favreau of Trust IT, and I will be moderating this webinar, which has been organized jointly by two projects, AI Sprint and EUCloudEdgeIoT.eu. What these two projects have in common is the partner IDC, the premier global market intelligence firm. Today, they will take advantage of the AI perspective given by the AI Sprint project, together with the computing continuum perspective given by the EUCloudEdgeIoT.eu initiative, to give us a European market analysis and insights on Edge IoT and on the role of AI as a complementary technology in the context of the computing continuum. So a quick word about who is online today with us. As you can see, the largest segment of our audience today is from research and academia, and they're followed by SMEs, which is always very welcome. A couple of words about housekeeping. There will be a question and answer session at the end, but you are most welcome to write questions and comments at any time into the Q&A box that you should be able to see at the bottom of your screen. Or if you can't find it, then just write questions into the chat. But please do so in any case. The more questions, the better discussion we will have at the end. So here, once again, is an overview of our program. As you can see, we will start the program today with a presentation of our two hosting projects. And we will start with the EUCloudEdgeIoT.eu, and more specifically, its demand-side project, UNLOCK-CEI. And our speaker will be Golbu Porabdoladian of IDC. So without further ado, Golbu, I pass the floor to you.
Thank you very much, John, and good afternoon and welcome everyone to this webinar. Let me just share my screen. I hope that you can all see my screen. Okay, so my name is Golbu Porabdoladian, and I'm a consulting manager in IDC, and I'm the coordinator of UNLOCK-CEI Project. As John mentioned, it's one of the sister CSAs of EUCloudEdgeIoT initiative. So just a few words about who we are. UNLOCK-CEI is a CSA, a Coordinate Support Action Project, which is funded under Horizon Europe program. And we started in June 2022, and the duration is 30 months. We have 6 partners. IDC is the coordinator, and then we have VDI, EGI, BlueSpecs, Trust IT, and Compla. What is the relation of UNLOCK-CEI and EUCloudEdgeIoT? Basically, UNLOCK-CEI is one of the 2 CSAs that have built the EUCloudEdgeIoT initiative as an umbrella initiative to cover all the existing activities in the ecosystem of the European research and innovation regarding cloud, edge, and IoT. So there are 2 CSAs, UNLOCK-CEI, which targets the demand side, and Open Continuum, which targets the supply side. So what is the EUCloudEdgeIoT in a nutshell? EUCloudEdgeIoT, as I mentioned, is an initiative which is initiated by the European Commission in order to create a sort of pathway for understanding the development of the cloud edge IoT solutions, but also to help the deployment of this solution across the computing continuum. So within the EUCEI, we are trying the 2 CSAs and also other research innovation actions that are part of the initiative are trying to promote the collaboration and cooperation among the different players and projects in the ecosystem in order to support the definition of the large scale pilots. As I mentioned, The community is coordinated by 2 Horizon Europe projects, 2 CSAs, UNLOCK-CEI, which targets the demand side and is coordinated by IDC, and Open Continuum, which targets the supply side and is coordinated by Martel Innovate. This is the landscape that we are talking about in EUCloudEdgeIoT. So as you see that we have on top, we have the initiative and the 2 CSAs, UNLOCK and Open Continuum. We have different clusters of the projects and research innovation actions that you can see under that are covered by this initiative: MetaOS projects, cognitive cloud, swarm intelligence, and open source projects. And then in order to establish the cooperation among these projects, a cooperation mechanism has been developed and is now operating in the forms of 6 task forces that you see on the left side of the image. And obviously, there are also interactions with other existing initiatives, such as Gaia-X, such as AIoTI, such as Insight, HiPic, IDSA, etc., and also some open initiatives like open source, standardization, a software forum, so far, so on. From this presentation about EUCloudEdgeIoT, I want to get back again to UNLOCK-CEI to talk a little bit about what we are doing in UNLOCK-CEI and why we are here. So what is the context of UNLOCK-CEI? Basically, the reason that this project is born is what's happening in the demand market of cloud edge IoT in terms of spending and adoption of these technologies. So if we have a look at what's happening in the European market of cloud edge IoT, we see that the spending on these technologies during the recent years has been increased, and the forecast shows us that also this investment and this spending is going to increase in the upcoming years. So according to IDC forecast, we expect that by 2026, the enterprise edge spending in Europe will reach to $75 billion. And this is a huge number. But what we have understood is that despite of all these investments, the industrial stakeholders and organizations still struggle to adopt and uptake the cloud edge IoT solutions across the computing continuum. And this paradigm shift is not an easy shift. It's not an easy shift for them to go on with. So in order to fill this gap, to fill the gap between the supply and demand, UNLOCK-CEI project is born in order to provide the insights and knowledge about what's happening in the market, in the demand market of the CI, and then what are the main drivers and business opportunities for the solution providers for the supply side, and help the supply side, the supply projects, to exploit and commercialize their solutions to the market. So the main ambition and goal that we have in UNLOCK-CEI project, as I said, is to facilitate and support the implementation and deployment of CI solutions in the market. And we are trying to do this by identifying that what are the main drivers, challenges, business opportunities, and what are the potential market scenarios. So we have five main objectives here in the project. The first one is assessment of the CI demand landscape. The second objective is related to definition a set of market scenarios and guidance in order to help the supply side to know that what's going to happen in the market and be ready to reach that market. The third objective is to build a dialogue with the demand side. So build a dialogue with the industrial stakeholders and bridge this gap between the demand and supply. The fourth objective is about the coordination and interaction with the supply side, so with all the RIAs. And finally, as every CSA, we have an objective of the awareness and impact generation. We started more or less 1 year ago. So far, we have interacted with demand and supply side through different approaches. Here just is a summary. We did a survey of Cloud Edge IoT demand landscape with 700 interviews with the players of the market across 5 verticals in Europe. We started to do deep dive interviews with the main value chain players in Cloud Edge IoT, in Europe to understand what are the business opportunities. We did 5 value chain adopters workshops for the 5 sectors that we are targeting in the projects. We did portfolio mapping and did the use case harmonization of portfolio projects. And we did different webinars and events to disseminate this demand market insights that we are generating. You can read our reports through the web portal of EUCloudEdgeIoT. These are the reports that have been published so far. There are other reports that are going to be published in upcoming months. So we have a report about Cloud Edge IoT demand landscape, about what's really the forecast, the spending, the adoption of the use cases, and also a report about the ecosystem of Cloud Edge IoT in Europe across the different sectors and how is the value chain shaped. And also a report about the technology scoping. So I would invite everyone to check these reports in the EUCloudEdgeIoT web portal. And the last word is that across the EUCloudEdgeIoT initiative, as I mentioned, we have a cooperation mechanism of 6 task forces, sorry. And each of these task forces are focusing on a specific topic which is relevant for all the RIAs in the ecosystem. This webinar especially has been organized in collaboration with Task Force 5 of the initiative, which is led by UNLOCK-CEI and IDC, so markets and sectors. So again, to RIAs who are attending this webinar, I would invite everyone to just check the website and see the task forces, and you can contact also all the task forces if you're interested to start a collaboration. So that's all from my side. I would like to now leave it to Danilo, who is the coordinator of AI Sprint.
Thank you, Golbu. Can you please move to the next slide?
I am in the next slide. Can you see the?
Oh, yeah, in the next one. I mean, let's start.
Right. Yes.
The content. Okay. Thank you. So actually, thanks for joining us, and welcome also from my side. I'm an associate professor at Politecnico di Milano, and I'm coordinating the AI Sprint project. As in the name, the core of our project is to develop solutions for AI application running at the edge of the network. So nowadays, everyone is talking about AI applications. Almost every week you have new articles in newspaper talking about something new coming from the AI world. And actually here I'm reporting some figure of the AI market worldwide that actually will be further analyzed in the following of this webinar. So you see that really we have a really impressive number, but actually there is a common consensus that the most innovative application will really come and happen because of the access of the application through the edge of the network. So indeed, while cloud computing has provided the needed processing power for training traditionally AI application, nowadays is the data actually are generated at the edge of the network. So is there where we can really process and I mean be time effective in the analysis of the data coming from these IoT sensor or whatever. Actually, if I mean we are moving toward the edge, however, new challenges arise from the infrastructure perspective because of the nature of the edge, which is including actually very heterogeneous application that sometimes can also disconnect to the cloud backend. Can we move to the next slide? Thank you. So what's the goal of AI Sprint? Our goal is to make the life of the AI designer and the system administrator of the edge system easier. So what we are doing is we are defining a design framework that works cooperatively with a runtime management middleware. And so what we are doing is we are developing simplified programming models where an application programmer can annotate their code to define some performance constraints and some accuracy constraints on their application. Then this code can be automatically transformed and dockerized actually in a way that they can be automatically deployed in the full cloud continuum stack. We are developing some specific tools that cope with the performance of these applications. So we have one tool that actually is profiling, is supporting the automatic profiling of the AI application and train some machine learning model that allow us to predict the performance of the application or components under unseen configuration. And we leverage this machine learning model at design time to identify also what's the deployment of minimum cost. So actually, in our framework, in a preliminary stage, the designer can say, okay, look, I would like to run this component in a drone with or without a GPU, what's best from the cost perspective. And according to the predicted workload, our tool identify the minimum cost deployment. Then when we move to the runtime, since actually performance workload can fluctuate, we have some management mechanism that adapt the underlying infrastructure in a way that the performance constraints are preserved. Finally, we are also following a secure computing paradigm. So actually, we have also tools that allow to run our application in a context where the opponent has a root access to the underlying hardware, and our application are in any case protected. And then finally, given our focus on AI, we are also developing some specific building block for AI application like federated learning that will be further discussed in the following, for privacy preservation, and also for a network architecture search, where actually given label data, the deep network with a higher accuracy is automatically identified. Further details are here in the paper listed here and also in our website. Golbu, can you please move to the next slide? Thank you. So actually, we are almost at the end of the project. We are close to 1:30. We are going to release our tool, and we are actually trying to bring some external user on board to test our application. This is a consortium. We are including 4 SMEs and UNLOCK-CEI, which is one European cloud provider. So that's really all from my side. If you're interested in the tool, you want to test our tool, please contact me. And then for the sake of time to go deeper with the market analysis, back to you, John. Thank you.
All right, thank you very much from both of you, from Golbu, from Danilo. Since we have a little time and you may not be involved in much of the question and answer session, I do have a couple of questions about the projects. I'd like to ask Golbu first. You talked about the task forces, of course, and they seem to be very important and very interesting. And you talked about being able to possibly join the task forces, but it's not 100%. It wasn't 100% clear to me exactly who can join the task forces. Is it projects? Is it individuals? Who are the people who could benefit from and could actually join?
That's a very good question, John. Thanks for the question. So, well, except from, let's say, one task force, which is Task Force 1, which is related to the strategic liaisons, the other task forces are basically designed for the projects, so research, innovation, action projects. Okay, so I would invite everyone. I don't want to go into the detail of the topics of task forces here, but I would invite everyone to check their website and see the topics of the task forces. And if they think that they are interested in a specific topic, just you can send an email to the task force leader, and then we can get back to them. The first task force, which is about the strategic strategic liaisons basically targets different initiatives, that are strategically relevant to EU Cloud Edge IoT. So if there are different organizations or different initiatives that are interested to start collaborating with EU Cloud Edge IoT under Task Force 1, then they are very welcome also to contact Task Force 1.
All right, thank you very much. Now I'd like to ask Danilo a question or two. From the diagrams you presented, you showed all the different parts of the continuum, of course, and I was particularly struck by the IoT part, which seems to be rather sensor intensive. That is I was wondering, or let's say sensor driven, are there new sensor technologies? I've heard this, that new sensor technologies are arriving that are also expanding the scope of possible applications. Are you seeing this happen in the project?
Yes, exactly. Actually, there are novel sensors that embed already some compute capacity, where actually you can start pre-processing the data coming from the sensor itself. So, for example, you have some cameras that embed kind of a neural engine where there is, for a small network, there is the full processing of the image coming from the environment. And in our technology, what we are also considering is the opportunity to partition the deep network in a way that the analysis of the data then is partitioned also among the multiple layer of the computing continuum, and that's all transparent. So, for example, in our tool is enough to bring some annotation, some code annotation, and the partition will automatically happen. And the best deployment will be selected by our tools in a way that the performance are guaranteed, and for example, you can minimize the energy, you can minimize the cost of the overall infrastructure.
Continuing on what you just mentioned about your tools, I'd like to ask another technical oriented question rather than a market-oriented question before we move on to the market-oriented discussion. You mentioned your tools, you mentioned a few new processes and things. Is it true that the introduction of AI into the continuum will also require new software engineering tools and processes? I'm getting that feeling from how you were presenting it.
Yes, definitely, because on one side, I mean, from the software engineering perspective, designing an application is challenging because the process is unstructured and is error prone. So, for example, if you are very good in image processing, also the experience you have, and you change domain usually it doesn't help much, because really the network are very specific, are very task specific. So it's challenging from the process perspective, and it's also challenging because of the framework. Nowadays, new framework come frequently. The current framework evolves also very quickly, and so it's really difficult for new developer to cope with these complexity. And actually, when we consider the device, also these makes also the things even worse, even more complex, because even if there are some standards, so for example, in AI Sprint, we are considering the UNLOCK-CEI standard, which allow to represent neural network in a standard coherent way across different framework. But actually, when you go to the edge device, usually have some custom framework that are vendor specific, and then I mean this is another source of complexity. So definitely today the life of the software engineer is not easy, and there are new solutions that hide this complexity are definitely needed from my perspective. Yeah,
thanks very much for these insights. So you can all see that there's a good deal of complexity, as Danilo said, in the new computing continuum, both at the level of technology and at the level of markets. And I encourage all of you to look carefully at both of these initiatives, both EUCloudEdgeIoT and also AI Sprint, to see the complementary visions of also the technology. But now we're going to come to the main event, so to speak, the next presentation will look at the the demand side market of Edge IoT as we move into market analyses. And our speaker will be John Gold of IDC. So John, the floor is yours.
Okay, great. Thank you, John. It's great to be here with you and to have a few minutes to talk to you about the research we've been doing within the UNLOCK-CEI project, looking at the computing continuum and in particular, so I will focus more on IoT and Edge at this point, and then my colleagues will focus more on sort of the cloud and AI side of things. But as the term computing continuum indicates, these terms and technologies do blend together and have a relationship with one another. And so we'll try to highlight sort of also what we've been learning about how these technologies relate to one another. So I'll dive in here. And to start with, I just wanted to set the scene with a top level view of the size of the market for the three technologies. Now, we can't add them together because they do overlap. So within IoT, there is usage of cloud and edge, and within the cloud spending total, IoT is seen as a factor driving increased data usage going forward within cloud, and certain parts of the IoT market are driving usage of edge, but there are also use cases for edge, such as content delivery networks that are largely outside of IoT. So these technologies, they've got their own trends and developments, but they're also closely related. And as you can see, the market size shows that we're talking about quite substantial markets already. IoT is the most mature of the three. It's been around, well, depending on how you want to define things, it's been around the longest. It's relatively mature, but it's certainly not fully mature. It's still growing quite rapidly, and it's a large market at 110 billion euros. IoT is a little bit less mature, but it's a larger market. And the reason why it's a larger market is because it includes quite a lot more more sort of technology components to deploy the various IoT solutions. Things like those end devices, for example, but we're including essentially the full IoT solutions, the sensors, connectivity modules, connectivity, edge infrastructure, cloud infrastructure, data center infrastructure, software applications, middleware, AI, analytics, and so forth. So it's including sort of the full package there, and it winds up generating quite a lot of spending already, despite the fact that we still have a long way to go in development and deployment of IoT. In Edge, Edge is the sort of the newest kid on the block here. It's particularly emerging in recent years, but it's already a large market, as you can see, at 36 billion euros. It's growing rapidly. All three of these are continuing to grow rapidly, and you'll see why that is as I move on to some of the subsequent slides. So that's a real top-level view of sort of the scale of these markets. And now I'll dive into some of the research that we've been collecting from a survey that we've conducted for the UNLOCK-CEI project. So for this project, we conducted a survey of 700 companies across Europe. And these companies were in a few selected industries. So agriculture, energy, healthcare, manufacturing, and transportation. So we were looking to understand sort of how things are developing across these different industries and to get a bit of a broad picture. Here you see when we're looking at usage and planned adoption of cloud edge and IoT. As I mentioned, cloud is the most mature, with over 70% of companies claiming they're already using it. But half of those are using it extensively, half of them only to a limited extent. So there's room for growth in intensity, but also you still see there's more companies planning to add cloud in the future. IoT and edge are less mature. You see edge is the newest one, the least developed. But in all of these technologies, there's a lot of planned development. Whoops, knocking things over. A lot of organizations planning to embrace these technologies and deploy projects for the first time. But then a lot of others, that light blue color, which is planning or likely to embrace these solutions more intensively, deploy more projects, deploy them more widely. So with that said, I'll dive into a bit more detail on IoT here. So in IoT, we have looked at, I've highlighted three of the industries in particular. And on the left, you can see sort of similar data to what we were showing before about the extensive usage versus limited versus planned, and so forth. And you can see that it does make a difference which industry you're in. The adoption has varied thus far. In this case, healthcare certainly leads. We do see transport and manufacturing, which aren't shown here, but they're also widely embracing IoT as well. Agriculture lags in terms of intensive usage, but as you get to the more limited usage and then the planned usage, you see that all of the industries really do even out over time. And they are essentially, we're seeing that all of the industries in Europe are convinced that they will use IoT, that they need IoT. They're planning to use it. And so it's a matter of time and developing the skills and the experience and the sort of the refined solutions in order to get there. But the education phase is sort of pretty well complete. Companies know that they need to use these IoT solutions. On the right, we've got sort of a similar picture. The maturity. We asked the companies about the maturity of the majority of their projects. So companies might have deployed an IoT project extensively, but we asked them about the majority of their projects. And here you see, again, light blue is the largest segment for agriculture. Most of their projects are deployed on a small scale still. So a lot of room for further development, a lot of work ahead. Healthcare is the most mature segment. Nearly half of the companies that are using IoT said that they're using it on a large scale already. So healthcare is embracing IoT, and we'll see a bit more about that about what they're doing with it in a moment. But I do want to highlight that it is these data do show that we're still very early in the market's development. There's a lot of work ahead. Okay, so what are companies using IoT for? So we've asked the respondents about quite a few different use cases, but this is hardly exhaustive. This could be a much longer list of use cases, but we tried to select a number of key categories, and you can see that at the top of agriculture and energy in both sectors, they said the most common use case is employee safety monitoring. We saw that also at the top in manufacturing and transport, or at or close to the top. So this is a real key issue across sectors. A lot of other use cases are showing up across sectors: asset monitoring and maintenance, asset tracking, video security and surveillance, and so forth. So there's a lot of use cases that are appearing across industries, though in many cases they are tweaked quite dramatically in their actual implementations in the specific industries. So So there's, you can see the base of the sample here was the companies that said they're using or planning to use IoT. So of those using and planning, just over half of agriculture said that they're using already the employee safety monitoring. Okay, so there's a wide range. You can see that over time, the planned usage sort of evens out. So companies expect that over time, they'll be deploying quite a lot of these different use cases, not just sort of one or two, but a wide range of them. And I wanted to note, I've put arrows next to several of these, so there's quite a lot, but the common point here is that these are some examples where a lot of the compute resources are likely to lean toward edge computing. So for example, with employee safety monitoring, you're going to need very rapid response if somebody's in danger, if a machine needs to stop instantly to avoid hitting a worker, then the sensors need very quick analysis and response and control over the device to shut it down. And these are the kinds of factors that point to cutting out the long distance travel of the data across a national network or a European network to some data center somewhere or a cloud somewhere, where the analytics might make a decision to shut the machine, but the data can be slowed across the network by network traffic or whatever, or just general latency due to the speed of light. And as a result, you don't want your critical use case like safety monitoring, or you don't want parts of that use case to travel far. So you have a reason, therefore, to apply edge computing closer to the sensors to react more promptly and shut things down. Video security is a different kind of a case where you are likely, you could send high definition video streaming across the network, but if you only are looking for specific things, then you don't need to stream all of that data across the network. Better to do local edge processing and reduce the amount of traffic you're sending across the network. In energy, that remote network management, that's another critical use case where you need immediate response in some cases. Process automation, autonomous vehicles, automated guided vehicles. These are the kinds of use cases where you need sort of that instantaneous response and control over machinery, and therefore you're going to need, you're likely to need a lot of edge processing. What we found in our research, though, is that across the board, while there may be an inclination toward using more edge computing for certain use cases, we still found that there's a lot of cloud computing used across the board as well. And the general situation is that these use cases will require a mix of both. You put certain functions at the edge and certain functions in the cloud as appropriate. Okay, so I'm better keep moving and keep an eye on time. So when to use edge? So I've just highlighted some examples, and we asked about the benefits of edge computing, security and compliance as data is not traveling. So again, so you don't want, if you don't want the data to leave your control, then you might use edge computing. If you can't rely on the network connectivity, or you want to cut connectivity costs, or if your use cases require ultra low latency, high reliability, you're likely to use edge. AI models are particularly helpful at the edge for enabling a lot of these kinds of instant response automation functions. And so they can be put at the edge. or they can be applied to data at the edge so that you don't have to send huge volumes of data across the network. So AI is certainly a key factor enabling a lot of the use cases that companies are planning to deploy. And it's also something that lends itself to edge computing as well as cloud computing. So it's sort of different purposes point to putting infrastructure where appropriate, rather than using all or nothing for a specific technology or use case. Okay, so digging a little deeper on edge usage plans. So on the left, we see the already using extensively in dark blue. Healthcare indicates that, so 15% said they're using edge already extensively. Healthcare, a lot of the industry has concentrated facilities and a lot of technology in those facilities, and also network managers and skilled workers in those facilities to manage this technology. They also are concerned about privacy, compliance, and so forth. So this is an industry that has a lot of the capabilities and the needs that point to significant edge usage. Agriculture has a lot of open fields, for example, where you might not expect so much edge, but agriculture is also expecting to use edge for a lot of things, such as automation of machinery, automation of like precision agriculture, and also for aggregating the data from a large number of sensors that may have very little resources on board. So you put a local gateway close to these sensors, and a gateway can handle some of that data crunching rather than having each device do so. In agriculture on the right, you can see that they're looking at using a lot of light edge, which really points to that edge gateway for aggregating data for sensors, but also heavy edge for things like automation. And you see at the bottom there the places where they're likely to put edge, and it's quite varied. But you see that, for example, agriculture, well, all of the industries are interested in using telco network edge. Agriculture is less interested in on-premises edge, more on device. So you see that each industry has its own preferred sort of characteristics and needs, but they are all looking at using edge for a variety of reasons. Okay, concluding slide, and I'm sure I'm over time, so I'll wrap this up. I wanted to highlight that there are still a number of challenges remaining that hinder deployment of IoT and edge. Cost, security, and deployment complexity are at the top on IoT, and so cost, security, and inadequate infrastructure at the top of edge. Also skills. What I think is the common denominator for most of this is deployment complexity, and even more so, sort of root cause is just the low level of maturity of the market. These projects remain complex because the use cases have not been refined, bulletproofed, and packaged for easy repeatability. It's still a lot of work, it's still complex, it's still difficult, and so that drives added costs, slower projects, bigger security risks, a need for more skills, etc. So that maturity is sort of the biggest factor, and that's a key thing for the industry to work on, and for researchers and academics and regulators and policymakers to work on as well. And so that would be sort of my concluding point. And with that, I'll draw to close and hand it back to John. So thank you.
Thank you very much, John, for this. let's see now. We actually have a question that seems to be very, very specific for you. So, John, so why don't we just take it now before we get to the Q&A session? I don't know if you can see it yourself, but it says you mentioned on slide 7, so about nearby gateways that acts as a connection point for data and processing devices. Does that make sense to you?
So I don't see the question. I will share the screen
okay.
again.
Then I will be, yes. So go to slide 7.
Yeah, I think you can see it.
Try to find it. Yeah, okay. And in any case, the question is mentioned about nearby gateways. And these gateways are more common for IoT protocols such as LoRaWAN, and how can MQTT or other communications protocols benefit from that architecture?
Yeah, okay. Not sure I've got a great answer for that, as we've been looking at sort of a more general level and not at the specific protocols. So yeah, I probably want to take a look at that, and maybe I can get back to the questioner. In this research, we were looking at the general perspective, but I'll take a look at the question and I can follow up.
Great, thanks very much. Yes, I'm sure there is really quite a bit of the technical discussion going around on the right protocols to be using, and I'm sure new ones are underway. So I have no doubt that it was an excellent question concerning how this all is going to evolve. And that is part of the much that remains to be done that you said, so to speak. Okay, very good. Thanks very much, John, for a really an extremely interesting presentation, very complete. But now we're going to change over to the other topic, which is less about Edge and more about the AI perspective on it. And so for our final presentation, our speakers will be Eva Zborowska and Jack Vernon, both of IDC. Eva, who was with not only with AI Sprint, but also with EUCloudEdgeIoT.U, and Jack is with directly with AI Sprint. So the floor is yours.
Okay, thank you so much. Good afternoon, everyone. Thank you for having us. I will probably be the one sitting in both reports. So I will try to share a few slides and few insights on cloud in the context of IoT and Edge, but also in the context of AI, hopefully making a good introduction to Jack's part on AI only. Let me quickly share my slides and let me know when you can see it.
Yes.
Okay, perfect. So a little bit coming back to what John was showing you, so familiarity and usage plans for cloud. What we see and other research that we run also confirms that cloud is probably one of those technologies out of those 3 that European companies and companies in those verticals that we surveyed are most familiar with. As you can see, no one says they are not familiar with cloud, and hopefully they are familiar and not just saying that for the sake of seeming to be knowledgeable. Similarly, for cloud usage plans, most of companies at this point declare that they are either extensively or to limited extent using cloud. Still, what we see is that there is room for improvement. There still are companies that are not necessarily, well, knowing how to use cloud, or a little bit struggling in a sense of finding the best application of cloud for their business needs. What is interesting is that quite often when we talk about cloud, we are not talking about companies that, well, when they say they are using cloud, they are using cloud exclusively. You can see that this research showed us that, again, for those industries that we surveyed, 5% said that they prefer public cloud exclusively. And these are usually new companies. These are usually companies that are cloud native, companies that don't have legacy IT, and that not necessarily is the case for most of the companies in Europe. As you can see, 85% of companies say that they are living in a hybrid environment, joining or combining on-prem with cloud, depending on what is needed. And I think it also shows you how important for companies is to look at which platform will be best from the perspective of application and workload. We no longer see companies in Europe saying, well, cloud first, cloud only strategy. Increasingly often companies say workload-led, application-led strategy. And once we know what this application requires, what we want this application to do, we choose the best platform for this application, for this application to run on. In terms of industries and cloud usage, I don't think there are huge differences, as you can see. Of course, we can say manufacturing, more companies saying using extensively, agriculture, not so much. But in general, I would say from the perspective of industries, it is quite a similar picture. It is a different story when we look at company sizes. We can see the larger the company, the more extensive the usage, the larger the group of those even using to a limited extent. And one of the reasons for that, we think, is that whether we like it or not, and sometimes cloud is presented as a technology that is relatively easy to use. You go online, you do some clicks, and you use it. It's not so easy in real world. And the larger the company, the higher the probability that they will have enough, mostly brain power. It's not so much about money. Money also plays a role, but it's mostly about ability to build competences, to build capabilities, to really use, leverage, deploy cloud. And we can see that big companies with more extensive IT teams are simply better at leveraging cloud for the benefit of their business. Even though companies are using cloud, companies are not necessarily super successful. You can see that 45% say that their projects so far were successful or very successful. I must say, and that can be just my preference, but when someone says moderately successful, which sounds like, well, it was okay, it's not necessarily what we wanted to achieve. So I would say most of the companies are not super happy with their projects. And we see reasons for that. We see that companies, even though they adopt cloud, even though this technology seems to be much more mature than others that we discuss here, still companies not necessarily know how to set expectations. They not necessarily they run cloud projects but fail to generate actual value from those projects. They lack ability to plan those projects the right way to make sure that everything is well, if you don't plan, you probably are not going to arrive at the results that you want. Lack of expertise that I mentioned, and I think this skills gap issue will be a recurring topic here, and integration challenges. And as I said, those integration challenges often come from the fact that you don't run individual applications on individual platforms. You need to integrate. The outcome very much depends on how well you are able to build a platform that combines cloud with other elements of your IT landscape in your organization. This one, maybe I fly over quite quickly because John talked about it a little bit, but cloud is becoming an enabler for new use cases. And as you can see, a lot of companies say that they are already using cloud for their IoT projects, or they are planning to use cloud for IoT projects. And again, maybe to add a little bit to what John was saying, it's mostly due to different models of data storage and processing, things that cloud enables, help with how devices can be managed in IoT management, but mostly I think is about those analytical and machine learning functionalities that are increasingly often, and I will show you a slide in a moment, increasingly often offered in the cloud. And now cloud and AI. As you can see, cloud is becoming the main platform for AI. In 5 years, we expect that more than 70% of AI platforms will be delivered as a service from the cloud model. And if you look at, for example, differences in growth rates between on-prem and cloud, it's stunning. We see that in public cloud deployments will grow at the CAGR for the next 5 years of 44.6%, which is crazy given that the average for IT market is still single digits at this point. So it surely be one of the most dynamically growing market in Europe. AI offers a lot of opportunities and some challenges. Opportunities will probably not be surprising here. Companies leverage AI to develop new business models. This data monetization theme is still ongoing. Companies realize that becoming a data-driven organization in today's world is a way to go forward, is a way to innovate and accelerate and be the first on the market. Process automation as a way to optimize businesses, optimize processes. They also see AI as a very good way to build ecosystems. And increasingly often companies realize that in today's world, they will not be able to create enough value themselves. So working with others within the ecosystem and creating a joint value for customers, whoever they are, is going to give them an upper hand. What I think is interesting is the human capital aspect of AI, because on one hand, we do see that AI can be a way to enhance and make an employee happier. So you take away some of the mundane day-to-day work, you give tools that make your employee work if not easier, then surely more efficient. But of course, we cannot forget about the challenges that companies see that are related to AI. And I think last few months, unless you lived under the rock, show us that this discussion about lack of trust and transparency, fear of biases, ethical concerns is going to stay with us, and this discussion about how this AI may impact a labor market. So for human capital, this surely is a twofold thing. One short slide on how we see companies today approach AI projects in their organizations. What we see in general, of course, we can say every company is different, every project is different, but in general, we see that there are companies, customers that are focusing on use cases. Quite often in this case, this demand comes from a line of business. The priority is simply to find a use case, add AI to that, and solve a problem. While others are starting to think about AI as an element of a wider company-wide strategy. And quite often in the second case, this approach comes from people who are more on technology side, maybe not necessarily IT team, but quite often from tech side. And in a wider sense, they are focusing on making sure that AI is not going to be used in some parts of a company, some use cases, just to solve individual problems, but more thinking about AI as a more general approach to how we run a company and how we can leverage this new technology to really change the way we run our business. And my last slide is just to show you what are the top 5 cloud-based AI use cases. I don't think they are super surprising. I think IT optimization is in general one of those use cases that leverage AI most extensively, even though it's not necessarily perceived as super cool and interesting, like drug discovery, for example. But it's one of those areas where applying AI-based tools really brings results quite quickly. What I think is, excuse me, what I think is interesting is how high next 5 years growth rates are. With the exception of, I think, the last one, products recommendations and shopping advisory use cases, all others are going to grow at the pace around 50% year on year. And I think it shows you, on one hand, how important it is to have those use cases, how much organizations in Europe today are looking to implement AI, but at the same time, it also shows you how important it will be for those companies to really leverage cloud for that. And one of the main reasons for using cloud here is surely access to computing power, access to storage space, but also the fact that increasingly often cloud providers are becoming providers of AI functionalities, AI tools that companies can use without needing to develop themselves. Still, they need to do a lot of things themselves, and I'm handing over to Jack to tell you more about AI itself. Thank you so much. And I'll start sharing. Unless we already have, I don't know, any questions I can answer. If not, we can take it later. Okay, Jack, over to you. You're on mute, I think.
Sorry, is that better? Can you hear me?
Yes.
Brilliant. Apologies, guys. Yeah, just going to say thanks to Eva for a really good introduction there, both to AI and cloud computing. Now, my presentation is going to take a slightly different turn just because in the course of developing the AI sprint, I was asked to look at some different specialist AI technology areas, those being auto ML or automated machine learning and federated learning. So that will kind of encompass the focus of my presentation. So first of all, covering automated machine learning, auto ML. What is it? Well, it's software that facilitates the ability to build, train, and tune advanced machine learning models.
Just a quick interruption, Jack, are you showing slides? Because if you are, we don't see them.
Okay. I am showing slides, or at least I thought
it was possible, but I just wanted to be sure. Yeah, here we go.
There we go. Don't worry, you only missed the title slide,
okay.
So nothing too exciting.
Proceed.
Brilliant. Okay, yeah. So auto ML systems are basically technology for which come with pre-configured models and algorithms where hyperparameter tuning happens in the back end of the software. And this is like a really typical key part of the data science process. And what's happened with this particular market here is that many of the early vendors in the space quickly advanced their capabilities to not just offer automated machine learning, but to offer capabilities around data processing, machine learning ops, trustworthy AI, data visualization, and management and governance. And many of these vendors have started to offer these capabilities in sort of standalone package offerings. So really, we've kind of seen an evolution of the markets, kind of a little bit away from auto ML into what we're calling at IDC AI lifecycle software. And yeah, I hope the diagram on the right reflects this. Now, what's driving demand for automated machine learning or AI lifecycle technology in general? Well, when you ask organizations, as we did at the start of this year, how they prefer to use AI capabilities, over a third, so 34% of organizations said that they plan to build custom AI models and systems. And I think the really core reason for this is that simply there isn't systems out there available that companies feel comfortable giving access to their own data. So they need to be able to build machine learning models with their own internal people and systems. There are other ways, of course, implementing AI, either just by buying technology off the shelf or consuming it passively through new features embedded with existing software tools. So, which is an increasing way that people are consuming AI, particularly given that most companies these days have adopted things like Salesforce and will be making that natural transition to picking up a few AI-based tools, say through Salesforce Einstein or other of their sort of traditional business systems. When we look at the opportunity in terms of which sectors, so who's doing like the most custom AI, you can see here that leading the way is distribution and services, manufacturing resources, and at the rear of the field, public sector and infrastructure. So I would just caveat this by saying that just because there's an indication that people want to build custom AI, it doesn't mean that all the demand in the market will flow to things like AI lifecycle or auto ML technologies, because you can build these, you can achieve most of what's possible within these systems through open source technology, as I'll come onto in a second. In terms of the market growth for AI lifecycle software, really impressive growth in this particular category, 36.2% compound annual growth worldwide. This is again quite a strong dominant share of public cloud uptake here. Going from $4.7 billion US in 2021 to 22.1 by 2026. The market in EMEA particularly strong in terms of its growth, in terms of adoption for this particular technology as well. Now, as I was kind of alluded to earlier, AI lifecycle tools spread across a full range of sort of fully coded options to low and no code approaches. And as Ava was mentioning before in her presentation, one of the problems with AI is that simply there aren't enough skilled practitioners able to take advantage of sort of fully coded technologies. And so we've really seen an emergence of people offering automated machine learning and AI lifecycle tools in the kind of low no code space. And there's some quite prominent European vendors here, in particular Dataiku, but then some challengers such as PKI and Monolith AI in the UK. In terms of who is present within this market, we see a strong activity from cloud vendors in particular. The kind of obvious reasons for this is that often they're trying to encourage greater uptake of services of the clouds. So they're often charging very, very low rates for use of their particular technologies, and that's working quite well for them. And also, as I was saying before, that there's a range of open source tooling efforts in the auto ML space, and they're often associated with established established data science tooling related to sklearn or keras. So yeah, we see automated tooling there. So I hope that's a good little overview of the AI lifecycle software markets. Oh yes, I've got this slide as well before I move on. So in terms of the sort of technology opportunities, I think there's greater opportunity for higher degrees of specialization in terms of focusing on particular industries. So I'll go back a slide, as with Monolith, they focus exclusively on providing sort of automated and AI lifecycle technologies to sophisticated engineering companies, like those in sort of semiconductor development or other parts of engineering. So yeah, there's definitely an opportunity for a greater amount of that to happen, but also specialization in model classes, as we've seen, like the emergence of transformer models, which have caught a lot of attention with ChatGPT. These models are really expensive to train, and you can see that there'll be definitely an opportunity for sort of automated or more aided tooling change related to the training and inference of those models, which will definitely be a boom for AI lifecycle providers. And yeah, also as well, another really big challenge, which I haven't really spoken about too much yet, is just optimizing the back end configuration of running and training models in the cloud. It's still really challenging, and unless you have a great understanding of technologies like Apache Spark, it's quite hard to take advantage of like scaled compute in an optimized way. So I feel like this is another area where AI lifecycle software vendors have a good opportunity to further develop their capabilities. In terms of like challenges to these vendors in this particular area, I think, well, there's alternative approaches, such as downloading models directly and not bothering to sort of train them too much on your own data. So just using generalized models, and there's marketplaces for these such as Hugging Face. So that's kind of like one challenge to the category. And another is transformers themselves, those that can be used to sort of generate really optimal pieces of code could encourage more companies to, instead of opting to purchase dedicated AI lifecycle software systems, to simply encourage developers to use things like ChatGPT as a way of cutting costs. So the other technology I was going to talk about was federated learning. Federated learning works by allowing AI model training to take place collaboratively across a network of nodes, with all data remaining at each node and not needing to be exchanged. A node could be a mobile device, a server system, a data center, a hospital, or an organization, or even a car. And only updated learnings to each node are shared So once shared, the update is immediately aggregated with updates from other nodes to improve the shared model and redistributed back across the network of nodes. All the training data remains at the original endpoint node device. And I hope this diagram kind of illustrates this, but to try and unpack it perhaps a little bit more, is that with a federated learning scenario compared to sort of traditional machine learning scenario, in that traditional machine learning scenario, often what takes place is that you're sending all the data collected at a particular node back to, let's say, the cloud or a centralized data center, and then you're doing all the processing there. So the issue with that is that you have to send data across the network, which is, of course, has some cost to it. And it creates an attack surface to be intercepted. And also as well, there's many regulatory systems, such as in the healthcare environment, such as in finance, where there is issues around simply sharing, particularly private data. So if you can locate sort of key AI processes at the edge devices themselves. And so training and inference can take place on the device. And instead of sharing any data across the network, you simply share aggregated updates to your model. You can basically reduce the attack surface, reduce the amount of information that needs to be exchanged across a network, and you can keep all the data at that edge environment, which can be really useful for regulatory reasons. So I've kind of explained already some of the benefits of this technology. The ones that I haven't actually mentioned on here is that there's definitely an ESG benefit possible from a reduction in sort of carbon emissions, which could be caused by the reduction in the need to send data across the network continuously. Also, there's opportunity for greater operational efficiency and flexibility. Just again, going back to the issue of sending lots of data across a network. So I'm just going to talk a little bit about one particular example of where this technology has already been used in the markets. And this is from a few years ago now. But Google implemented federated learning on the Google keyboard, or the Gboard on Android smartphones. And it's essentially a language model which is localized to each individual's phone. So as you are typing messages, sometimes you might use new bits of vocabulary, which are kind of maybe specific to you or specific to your region. And instead of sort of sending all that information back to the aggregated autocomplete system in the Google Gboard, instead, you update your model locally, and some of the hyperparameters of that model are then shared with both other nodes or smartphones in the network, and then kind of a centralized model as well, and then re-aggregated out back across the network in the system I described before. So this was a much more efficient way for Google in particular to navigate kind of the updating of their autocomplete system on their keyboard. So that's where it first came to prominence. Now, I also wanted to talk about a number of different paradigms related to how federated learning can be deployed. So increasingly, we're seeing it move beyond kind of the sort of traditional application. A traditional application of federated learning has been on heterogeneous data. So data with the same features, but different in terms of its orientation or location. So I think that would be akin to the Google Gboard application I was talking about before. But we've also seen some vendors being able to offer heterogeneous data configurations. So that's where there are different data sets with users in common that do not share in the same features. So what this can essentially do is allow two organizations to collaborate in developing machine learning models or learning from each other's data without actually sharing it, which is, I think, a really potentially transformational capability. So in vertical federated learning, you need to have just simply users in common. And then you have transfer federated learning, which involves using machine learning to sort of analyze a small subsample of common users, and then identify other common data points which could be used in the pooled model. A number of companies are already exploring this. For instance, I believe that there is a trial running between a telecommunications operator and a small bank to see if the bank can improve its modeling of credit risk and fraud with using some data from the smartphone vendor, but without actually sharing any of that data, and instead you were just sharing an aggregated model with model updates. So yeah, trials of this are currently underway, and yeah, very interesting to see the direction the technology goes in. Again, in terms of the technology landscape of vendors, there's a mixture of open source and fully commercial technology efforts into federated learning platforms. The market's made up of prominent startups and cloud vendors today. Yeah, one of the most prominent is in Europe is a company called Sherpa AI, which was I took a slide from their website on the previous slide. But yeah, there's a number of others too. TensorFlow federated learning, that's also a pretty popular technology as well. Yeah, so to sum up, I think there's a big opportunity related to federated learning, particularly in terms of the fact that there's going to be greater regulation of how organizations use data and use AI, and federated learning could play a key part in ensuring that data does remain relatively private and localized to a device or particular endpoint or organization. And I think with heterogeneous data frameworks as well, this could create a genuine market for multi-party data collaboration and exchange, which we haven't really ever seen take off to date. But yeah, it could be a really interesting and emerging field. I think the biggest competitive, well, not necessarily competitive challenge, I perhaps should have phrased that differently, is really related to the fact that we haven't seen too many scaled deployments of this technology outside of large tech companies. So I think the industry kind of has a bit to prove in terms of of activity and feeling like sort of scalable results with the technology. But I think in the years to come, that should be addressed. And with that, I'd like to, I don't know who I'm handing back to. I apologize, but yeah, that concludes my sort of introduction to two AI technologies that I looked at in the AI sprint report. John,
Thank you very much, Jack. That was a fascinating presentation. It looks like federated learning is a real game changer. At this point, we now go to the question and answer session, and we are getting some questions. If you could turn on your, all of you speakers, turn on your videos. We do have a few questions here. And I'd like to actually start with the last one that has arrived, which is a more generalized question. It's about, it says that we've seen some great presentations on the state of AI and CAI today, but which R&D topics should we prioritize in particular for the next period? So I'll give some of you a chance to think about it, but I'd like to go back to John Gold to get the first ideas about where you are seeing that they need to do more. You said there was a long ways to go in many ways. So where should they start?
So yeah, it's a great question. I don't have a simple answer.
I believe that.
I mean, when I'm looking, so I concentrate quite a lot on IoT, and the thing about IoT is that it's not really one market. It's hundreds of different markets for individual use cases and solutions. We did see that there's commonalities in solutions across and use cases across industries, things sort of fundamental use cases like asset tracking, environmental monitoring, and security, surveillance, usage of cameras, like image analytics and things. So there are fundamental tools that are used across them, and so a lot of work needs to be done both in terms of these fundamental tools, in terms of refining the the tools themselves, like AI, you know, is changing very rapidly, right? So that so a lot of work is needed in individual tools, but then or AI as a general category, image analytics or other kinds of use cases of AI would, you know, in particular, and then individual use cases across IoT and CEI. So there's a lot needed in kind of horizontal technology categories, and then also in many different vertical solution areas. I guess one area I'd note would be in terms of the use of 5G networks. We did see that 5G was mentioned quite a lot in our research and in interviews as a crucial technology for enabling a lot of these use cases. And we see a lot of industries are looking at using 5G, both public and private versions, in order to enable things like factory automation, general automation, and also autonomous vehicles. So there's a lot of interest in these sort of leading edge use cases. They will make a lot of use of cloud edge, IoT, and AI, and a lot of them sort of are very early in their development. And 5G is a key part of that. So I think a lot of work needs to be still put into enabling 5G and enabling 5G to enable the next steps with all these use cases. So that's my long-winded and very broad answer.
Thanks very much, John. I'd like to ask Ava now another question. You said something pretty frightening, Ava, during your talk, saying that it's mostly the large companies who are succeeding as of now, and it was touched on by the other speakers too. Like Jack talked about the problem of training your own models. We know how expensive that is. Are we headed towards a divergence? The big and the small, and the big are going to dominate, and it's going to be that way. And the SMEs are going to have no opportunities. Is it going that way? And is there anything we can do about it? You talked about skills development. How can people acquire the skills necessary to overcome this divide between the large and the small?
Okay, so just I don't want to say to sound like I'm going to scare anyone saying that SMBs are doomed and have no chance in this race. It simply is what companies are declaring at this point. So those were more like comment to the results of the survey, not an attempt to say that SMBs do not do anything. They do at a smaller scale. And I think for SMBs, it may be really difficult for them to do everything themselves and to do everything internally. So I would say, of course, think about building capabilities. Think about having people internally who understand, but maybe they don't need to be super experts, but find partners that can help you. You can partner with cloud providers, you can partner with academia, you can partner with different types of associations that focus on topics, on technologies that are of interest. You can also work with any type of technology vendor, from vendors through cloud providers, telco companies, different types of service or software providers. Find those who will help you. The only thing that I would like a disclaimer here, work with partners, but make sure that knowledge transfer is assured. So you do not put yourself in a position where you depend on your partners, and once they, for some reason, are no longer available, you don't work with them, something changes, you are left to your own devices and you don't have those devices because there's nothing left. You relied 100% of whoever you worked with. So I would say working with external companies and slowly building those capabilities internally is a good way. Also, look at what is happening on the market. We can see that many cloud or technology providers who also understand and see the issue of skills gap. They are heavily investing in education, in offering courses, in offering trainings, in helping customers or potential customers to build their competences for their organizations. So look at the market and see where you can learn. I think that at least for IT industry or technology industry, it's not surprising. We will need to learn all the time. It's not like we are going to say, okay, we know everything and we can work with whatever we have. It will probably help us for the next 6 months, and probably within a year we will be like, well, yeah, we need more knowledge, we need more capabilities. So keep on learning. That would be my maybe not super new, but hopefully useful advice.
Well, it sounds like very much like the long road ahead that we heard about first from John, and that everybody is saying this. It's going to be a continuous process. Yes,
Of course.
This all makes very much sense. So, Jack, I have a last question for you. Last couple of questions, actually, but one is that came from our group was federated learning sounds very exciting, but is it a market yet? To your understanding, is it just expectations, or is there really a market that is emerging now for federated learning?
Yeah, I mean, I think one of the biggest opportunities is definitely in healthcare, particularly in the UK. Hospitals aren't allowed to share particular bits of X-rays or scans, and if you want to build models accurate enough to sort of identify issues with those scans at a global level, you need to be getting into orders of magnitude of data, which is beyond, say, your single healthcare setting and environment. So I think there's such a clear need there. In terms of whether it is a market yet, I think it's still very early, and I think the players are still literally just getting technology off the ground and running their first couple of trials with their early clients. So yeah, I think that's about as much color as I can provide.
Okay, very good. You also have a more technical question in the Q&A section, but you are free at this point. You could answer it directly, writing into the Q&A session in that case.
Do you want to read it out so everyone's clear on what it is? And then I've read it, but do you want to just read it out so everyone's clear on it? Oh
yeah, sure. Mr. Vernon, can you elaborate on the heterogeneous data? Your point of view on heterogeneous data is the data format, data structure, the source. If yes, do data stay untouched and are fed into training ML models, or are they converted into a common schema in order to enable seamless ingestion of data into ML models?
So my understanding is the way that it works is that often you'll have a federated learning technology provider, which would situate its technology at both customers' node endpoints. And so, company A or party A might be contributing around 10 columns of data on a particular user, and company B might be contributing 5 totally different columns. And from my understanding is that, yes, the models live at the edge, and therefore there doesn't need to be like an exchange or a conversion into a new schema. So I hope that makes sense and answers the question.
Well, I hope so too. Okay, I'm afraid we have run out of time. We have to respect our audience and their other obligations. So at this point, I would like to thank our speakers, and I would like to remind you that this is actually a part of a Market Outlook webinar series, and you have the opportunity also to look at the first one of these, which happened last November. It was an Edge Computing Market Outlook webinar. Took place. The recording is on the site of AI Sprint, and you are free to look at it directly on YouTube or on the site itself. Other than that, I also encourage you to stay connected, so to speak. Many questions had to do with what you could do furthermore within the projects, like within the task forces or things like that. So here's the information you need to contact both the AI Sprint and the EUCloudEdgeIoT projects, and they look forward very much to hearing from you. So once again, many thanks to our colleagues, especially from IDC, who did such a wonderful job of presenting many different aspects of the Cloud Edge IoT ecosystem. And thank you very much, and looking forward to seeing you the next time.